Hello there, I am Akash Char. I am currently pursuing my BSc 6th semester in Geology Honours from JK College, Purulia. Today, our topic is tidal environment. And this is our content. At first, we will discuss about the introduction, then tidal environment, then what is tides and the types of tides. After that, what is CGK classification of coast, what is flood tide and ebb tide, and then supratidal, intertidal, and subtidal environment. And at the last, the tidal sedimentary structure. The first few topics will be discussed by me, and the rest of the topic will be discussed by my classmate Bidyut Char. Introduction. The sedimentary environment is the specific depositional setting of a particular sedimentary rock and is unique in terms of physical, chemical, and biological characteristics. The physical feature of a sedimentary environment include water depth and the velocity and persistence of the currents. Chemical characteristics of an environment include the salinity, that is the proportion of dissolved salt, acidity or basicity, oxidation potential or EH, pressure and temperature. The biological characteristics are mainly the assemblage of fauna and flora that populate the setting. These conditions, combined with the nature of the transporting agent and the source area, largely determine the properties of the sediment deposited within the environment. Tidal environment is one of that sedimentary environment. A tidal environment is that part of a marine shore which is regularly submerged and exposed in the course of the rise and fall of the tide. Now, what is the tide? Tides are the rise and fall of sea level caused by the combined effect of the gravitational force exerted by the moon and the sun and the rotation of the earth. There are mainly two types of tides, the spring tide and the nip tide. Spring tide occurs when the sun, moon, and the earth arrange in a straight line. As you can see in this diagram, the sun and the moon and the earth are in a straight line, or we can say that the sun and the moon and the earth makes an angle of 180 degree. But in the case of nip tide, you can see that the sun, moon, and the earth makes an angle of 90 degree. As the resultant force in the case of spring tide is more, that's why the spring tide is more strong than nip tide, and in the case of nip tide the resultant force is weak. That's why the nip tide is not that much strong relative to the spring tide. Next, CGG. Now, what is CGG? In astronomy, a CGG is a roughly straight line configuration of a three or more celestial bodies in a gravitational system. As you can see in the diagram that the sun and the earth and the moon is in a straight line. This is called a CGK configuration. If we go to the previous slide, let me remove this. In the left side diagram, that is the case of spring tide, the sun, moon and earth are in a straight line. This is a CGK configuration. But in the nip tide, the sun, earth and the moon is making a 90-degree angle. This is not a CGK. Next, now let's see where the tide dominates more. Tide dominates in the marginal part, that is the junction between land and sea, where river is absent or wave action is nil. So areas are basically characterized by broadly spreaded, gently dipping landscape. The rise and fall of sea level caused by astronomical condition is regular and predictable. There is a great range in the magnitude of this daily or semi-daily change in water level. Along some coast, the tidal range is less than 0.5 meter, whereas in the Bay of Fundy in southeastern Canada, the maximum tidal range is just over 16 meters. We can divide the coastal region on the basis of vertical rise of water takes place during the tide. If the vertical rise of water during tide is up to 2 meter, then the coast is called microtidal coast. If the vertical rise is in between 2 to 4 meter, then it is called mesotidal coast. And if the vertical rise of water is greater than 4 meter, then it is called macrotidal coast. Next, flood tide and ebb tide. Migration of tidal water from low water level towards high water level is called flood tide, and the migration of tidal water from high water level towards low water level is called ebb tide. From this animation, the migration of tidal water from low water level towards high water level and from high water level towards low water level is easily understood. If the water migrates from low tide to high tide, then this is called flood current. And if the water migrate from high tide to low tides, then it is called ebb current. And the vertical thickness between low tide and high tide is called tidal range. Next, supratidal, intertidal and subtidal environment. There is a difference between tidal environment and the other environments. Generally, all other environments are characterized by sediment and structure produced over a long period of time, whereas in the tidal environment, it changes very frequently. So, with the rise and fall of the level on a daily cyclic basis leads to the exposure of sediment into different platform. Supratidal environment. Supratidal environment is where sediment is deposited above normal high tide by spring and storm tide. The sediment is exposed for long periods to subaerial condition. Then comes the intertidal environment. It is where the sediment is deposited between normal high tide and normal low tide. The sediment in this zone is generally exposed twice a day to subaerial condition at low tide. Tidal channels are common in this zone. Then comes the subtidal zone. Subtidal zones occurs immediately seaward of the normal low tide mark or in a tidal channel dissecting the flat and is rarely exposed to the subaerial condition. In this slide, I have given the definition of the environment. Okay, that was all about my part, and the rest of the topics will be discussed by my classmate Bidyut Char.
Hello, I am Bidyut Char and my topic is tidal sedimentary structure. So first we discuss about herringbone crossbedding. Herringbone crossbedding is a form of crossbedding in which the four sets in successive sets are directed in opposite direction, so producing a structure which somewhat resembles the bones of fish. The bipolar orientation of a four sets seen in herringbone crossbedding is commonly generated by the reversing currents developed in many tidal environments. Now we discuss about flexure, lenticular and wavy bedding. These are typical structure of intertidal environment. Flexure bedding is a type of ripple bedding in which thin streaks of mud occur between sets of cross-laminated or ripple-laminated sandy or silty sediment. Mud is concentrated mainly in ripple troughs but may also partly cover the. Lenticular bedding is a sedimentary bedding pattern displaying of alternating layer of mud and sand, in which sand lenses occur between the muddy sediment. Wavy bedding. If mud and sand deposits are equal, wavy bedding is produced. Wavy bedding marks the boundary between flexure and lenticular bedding. Reactivation surface. Often the migration of ripple is interrupted and the ripple is eroded back and then buried by a new wet form. Such interruption produces a teeny erosional surface between cross strata known as reactivation surface. This is formed because of alternating current direction and variation in flow conditions. Lastly, we discuss about tidal bundles. Due to the changing in current velocity, the thickness of the lamination may change, which is basically attributed to the spring and nip tide. Tidal bundles reflect the increasing and decreasing strength of tidal current through the lunar cycle. During the nip tide, when the tidal current strength is weakest, smaller quantities of finer grains are deposited. As the tidal variation grows larger towards the spring tide, larger quantities of coarser material will be deposited, which results in an increasing bed thickness. Bed thickness will be greatest at the spring tide and then decreases as the tidal variation grows smaller towards the nip tide again and the thinnest beds.
These are the references. Acknowledgement. Thank you. Thank you for listening.